Hello everyone. I sincerely hope this is the last time you have to hear from me through a screen instead of me being in front of the class and giving you these notes directly. So we'll walk through this back to our Intro to Angles packet. I believe I recently sent out the notes for the entire set that we'd gone through. We did questions 1 through 7 together, asked you to do questions 9 through 13 on your own at various times, whether it was for one class, we did a little bit of like back and forth with that bisector thing. We came back to question 6 and 7 after we did the other stuff, but it's fine. All 13 of these questions should be available to you in Google Classroom right now. Go ahead and look for those notes. Make sure that you got answers here that hopefully make a little bit of sense. With that said, there are a few other practice problems, of course, in the rest of this packet, and I'll leave a lot of those to you on your own. This last page looks somewhat ridiculously challenging, but as long as you're clear about what the directions are stating, then I think you're going to find that it's not so bad. The good news, at least with this back page, is that there's no algebra, no solve for x. Well, you've got an x and a y down here, but you don't have to solve anything for them. Now, where I'd like to focus on for today is we're just going to go through these 3 questions on this second to last page, questions 20 through 22. You're going to notice a lot of similarities about these, but once we're done with these 3 questions, I'm going to bring you into Delta Math because I am going to give you an assignment, I think about 30 questions worth, where we are going to have to answer some questions about these things. You will have to do some algebra. You will have to understand what the relationships between these angles are. Now for 20, 21, and 22, the reason why I like these problems a lot is take a look at what you're told in each of these questions. The measure of angle 1 is 3x plus 4. The measure of angle 1 is 3x plus 4. The measure of angle DUK is 3x plus 4. Then we get to 4x minus 6, 4x minus 6, 4x minus 6. All 3 of these questions are giving you 2 angles that are the same pieces of information. All 3 of these questions are solved in very different ways. So that's the most important part when you go to start these questions. Please make sure that what you're about to do makes sense. Please make sure that you're reading through all of the directions. You may not assume that a figure is drawn to scale. So for example, in question number 20, I don't remember what the answers are right now, to be perfectly honest. But right now, angle 1 looks obtuse. It looks obtuse. But because I may not assume that a figure is not drawn to scale, that could be 3 degrees for all I know. So please, the drawing is there so that you're able to label things appropriately. It is not the end-all be-all. It is not if I get an angle for number 1 that is less than 90, it doesn't mean I'm wrong, it means the drawing is wrong. So, with that said, same deal when you start these questions. I would love to see you go in and do your labeling. Here's a 3x plus 4 for angle 1. Angle 4 is 4x minus 6. Let me actually do number 21 at the same time so you can see the similarities and differences. Of course, the similarities are angle number 1 is 3x plus 4. That's not going to change. This time, for my second angle, I'm given angle 3, which is 4x minus 6. You can see through these 2 drawings that the relationship between the 2 angles that were given is much different. Now, in both of these questions, we'll be asked to solve for x and find the measure of angle 2. We'll get to that when we get to it. It's just a matter of, again, remembering the difference between how we solve one of these, how we solve the other. You can feel free to pause this video right now and try these 2 questions. Make sure that you get the correct answers or answers that hopefully make sense for you. Then reconvene, see how we did, see if your answers compare to mine. That said, here in question number 20, I have angles 1 and 4 that together lie on the top of this straight line. And as a reminder, the most important number that we will discuss in this class is 180 degrees. And if I've got 2 angles that together form a straight line, that means I'll be adding some stuff together to equal 180 degrees. It's then just a matter of making sure that I throw my 2 angles on the same side when I go to do my next step. I am combining like terms. I am not moving the x's from one side to the other in this problem. Instead, I'm saying 3x plus 4x is 7x. 4 minus 6 is negative 2. Again, don't freak out when negative numbers happen. They will happen. And then you'll go ahead, you'll solve in your normal fashion, get what x is going to have to be after all of this mess. And I do believe that x is equal to 16. Great. I'll pause here. And we'll go to question number 21, make sure we get the correct value of x here, make sure we have the correct relationship for x here. Straight line's not going to help me right now because I don't know anything about angle 4. I also don't know anything about angle 2, so it's not going to help me with this line either if I compare it to angle 1. No, all I have are angles 1 and 3 that lie directly across this intersection from one another. Angles 1 and 3 that only meet at a single point that we call the vertex of each angle. And again, our word for that, even though it's not straight up and down, we talked about this, the word vertical for our vertical angles means that they share a vertex. And if that's the case, you are talking about two angles that are equal to one another. Yeah, sometimes it will be I'm given two pieces of information and those two pieces of information have to match. Now that they're on different sides of the equal sign, though, yes, you do have to worry about where you're moving stuff. Again, I spoke about this in one of the classes at least, but please don't feel like you can't move the x's to the right-hand side of the equal sign. I know that many of you are so focused on always getting it to the left-hand side that you're going to sleep on a pretty easy way to get through this. I know how much everyone hates negative numbers. And if I subtract 4x from both sides in that first step, I have negative x, and not a lot of people like that. But if I get 10 equals x here, that's done. And you can write it as x equals 10 at the very end if you'd really like. It's not going to change anything. Then it's all about trying to find the measure of angle 2 in both of these questions. Up here, we get to use the idea that we just came up with. Hello, vertical angles, angles that are directly across a vertex from one another. If angle 4 in this drawing is 4x minus 6, angle 2 in this drawing is 4x minus 6, and we don't have a lot of math to do. If we take the value of x that we just got and plug it in, then we're going to be good. And after all of that mess, what we're going to find is that, I like to change my colors here so you see where that 16 is magically coming from. 4 times 16 is 64. Minus 6 gives us our final answer for this question, that the measure of angle 2 is 58 degrees. And that does look like it could be the case in terms of, does that angle look acute or obtuse or whatever. Down here, you're going to notice very quickly when you plug in an x equals 10 that you don't get the same sort of idea where your drawing makes a little bit of sense. The other problem, though, is we don't know anything about angle 2. At least in terms of, can I put something in here in terms of x? Not really, because the only angle to compare it to is angle 4. I don't know anything about angle 4. So your first step would be, again, take that x that you just found and plug it in somewhere, anywhere, doesn't matter where. Whatever is going to be the thing that makes you feel the best, the most comfortable, plug in that x equals 10 to one of the angles that you know in this problem. Then try to figure out where you're going. 3 times 10 is 30. 30 plus 4, I'm pretty sure you know is 34 degrees. And so yes, that is saying that this right here is a 34 degree angle. Again, not drawn to scale. Well, we can now do the sort of opposite thing that we did in question number 20. Where the first thing we did, we talked about something being 180 degrees. Then we used vertical angles to find what that remaining piece was. Now we're going to do the opposite. We used our vertical angles to find what the measure of angle 1 and angle 3 would be. And then I can go to my straight line and talk about how that is a linear pair and that I have to take my two angles, add them together to get 180, or 180 minus the angle I know gives me the angle I don't. And the measure of angle 2 is 146 degrees. Again, does that look like a 146 degree angle in this corner? Absolutely not. But again, that's what we mean by a figure is not assumed to be drawn to scale. Could it look right? Sure. Does it have to? Not even close. So please don't worry about that. The last question on here before we break and do delta math, again, I just want to make sure that we're not falling into the habit of saying it's got to always be one or the other. That these two angles are equal to one another, like in 21, or that these two angles add together to equal 180 or 90 or a third angle or anything like that. There will be different scenarios, and you have to be on the lookout for each of them based on the information that you're given for each problem. And in question number 22, before you get to anything involving those x's, one more time, please pay attention to the directions that are given to you. In the figure at right, UN, this gray, the arrow that goes out from the vertex and just continues all the way out this way, bisects angle duck. UN is an angle bisector. It does the cutting. It takes your angle and splits it into two equal parts. Again, as long as those two angles are labeled in the same way, the same number of curves, sometimes you'll see those little tick marks on them as well. I kind of like to use double curves whenever I can, just so it's very, very clear, hey, these two angles I'm trying to label in the same way right now. So that I know those two little angles based on just this before we do anything with x's. It says those two have to be the same. Then I can hit my normal thing and say, angle duck is 3x plus 4. Again, if you're having difficulty with it, connect the dots. I have the benefit of using an iPad to literally highlight angle DUK. And this whole thing in green. In the notes you saw me do a big curve like this, point to it and say, this thing right here is 3x plus 4. Then I'll go and talk about angle NUK, I guess. Sure. NUK. And this one right here is a 4x minus 6. Again, as I mentioned when we went through these problems the first time, the most common wrong answer here is to do exactly what we did in question number 21. To say 3x plus 4 equals 4x minus 6 because here's a drawing where we were told based on this bisect idea that two angles had to be the same. Yeah, two angles here are the same. It's the 4x minus 6 and the whatever's supposed to be over here. Luckily, we don't have to come up with a third thing in terms of x. What we have here is our original thing that said we have these angles that are bisected. We have two angles that must be exactly the same. And if that's the case, as soon as I know that this angle here is 4x minus 6, I also know that the angle on this side would have to be 4x minus 6 as well. They've got to be equal if this is an angle bisector, if this angle was split into two equal pieces. And so we are going to have a scenario that says two angles add together to equal a third angle or a third measure. It's just not saying 3x plus 4 plus 4x minus 6 equals something. What it's actually saying is I have to take my original 4x minus 6 for angle NUK, add in another 4x minus 6 because of the whole bisector thing, because those two small pieces have to match. And that all together is going to equal my big angle of 3x plus 4. This is the most difficult of these kinds of equations where you have to think about this idea of, oh wait, I know I have a 4x minus 6, but it's got to go in two different places. Once you have that, this becomes just the same kind of question we saw in number 20. It was two angles added together equals 180. Now it's two angles added together equals 3x plus 4. Doesn't change how we do it by combining like terms. It's just, okay, we'll have an extra algebra step here because now we've got to go ahead and move the x's all to the same side before we do anything else. Again, some of you may like to do multiple algebra pieces in the same step, like add the 12 to both sides in the previous step instead of what I'm about to do right now. But generally, when I do these notes, I'd like to show you every single step because I know not everyone is going to be fully comfortable with this idea. And I'm going to get that 5x is equal to 16. Oh, that's not pleasant, is it? Well, that's fine. There's nothing wrong with getting a fractional or a decimal answer. X equals 16/5. Probably you don't want to leave it that way, though. Grab a calculator. You're not going to have a number that's too difficult here. X equals 3.2. And that's fine. You are more than welcome to have an answer here that is a decimal. I'm not going to give you any decimals right off the bat that are ridiculously ugly or anything, the ones that continue forever and don't repeat. 3.2 is perfectly fair and perfectly normal. This question also asks you to find the measure of angle DUN, which is DUN, connect the dots. This one right here, the 4x minus 6, because it's the same as the DUK, 4x minus 6. And so to end this question, we would actually have to say, what is 4 times 3.2 and then minus 6? Well, 4 times 3.2 is 12.8. 12.8 minus 6 means that the measure of angle DUN is only 6.8 degrees. Don't believe me? What can you do to check your answer at the end? Of course, plug it back in and make sure you get something that makes a little bit of sense. If this angle is 6.8, then this angle had better be 6.8. And 6.8 plus 6.8 means that this should be 13.6. And 3.2 times 3 is 9.6. 9.6 plus 4 is 13.6. We have our correct answer, and it's a decimal, and that's fine. Again, please don't freak out when you see decimal answers. They will exist. And sometimes in Delta Math even, you'll be asked to round to the nearest tenth or the nearest hundredth, so please keep that in mind. But more so than the decimals, the important thing that I want to make sure you come out of this knowing is please don't try to treat all these questions the same way. The more stuff you label, and the more you look at your directions and come up with any information like that word bisects or the words complementary, supplementary, what have you, get that information on your drawing or in your equations as soon as you possibly can. That's going to make your life a lot easier moving forward. Again, this is the only additional page I'm going to go through with you in the notes. If you wanted to go back, look at questions 14 through 19. If you want to move forward and try those somewhat tricky, not even algebra questions, but numerical questions of 23 through 25, you're welcome to do so. But these three questions right here, again, wanted to give you this idea of how can you see the same given information, the same 3x plus 4 and the same 4x minus 6, but very different solving styles for those kinds of equations. With that said, I did say I was going to give you a Delta Math problem here, so let's go ahead and go to that. You're going to see this intro to angles thing in Delta Math, and there are a few different sections here. I want to walk you through one of each type of problem, just so you can see what it means. The first one says angle bisector, and it's actually going to be kind of interesting because the first thing you're going to have to do is draw an angle bisector. Here's angle LMN, it's told it's 98 degrees, and it says go to angle M, go to the point at point M, and drag away from it to find a line that, oh, look, here's my ray. Here's my thing that's going to cut this angle into two pieces. But an angle bisector doesn't just cut it into any two pieces. I have to wait until I see that those two small angles are going to match the ones that I have there for LMO and NMO. And once I have the same number for both, congratulations, I've drawn an angle bisector. But then when I scroll down, it's actually going to ask me one additional thing. It's going to say, which of the following statements is true? And you're going to see some stuff that looks like this. Now, keep in mind, you've got a couple of small angles, you've got a large angle. You just want to see, based on the literally algebra of it, in terms of multiplying or distributing or which two angles are equal, which of those statements is going to be true. Luckily, look at the top of your screen right now. It says the angle LMN is equal to, angle LMO is equal to, angle NMO is equal to. Only one of those four statements is going to be true based on those numbers. And for this particular problem, yeah, those two angles are supposed to match. Cool. As a reminder, Delta Math is really nice. Even if you get a question right, it's going to go ahead and go through that entire ridiculous, I will explain to you why it is that these answers are correct and move you to the next one. For all of these, you're again going to have that penalty 1.5 or 0.5 off. So for every 2 questions you miss per section, you're going to have to get another one right. The good news for most of these sections, you don't have to get a lot of questions right. This one says do this 3 times. Angle addition and subtraction, hopefully will be the one that goes the quickest because it is simply numerical. No x's, no nothing. It's just a matter of making sure you're looking at, okay, it's telling me about angle PNO. I'll trace it out. I'll draw it out. I'll see it on here. Great. The only thing to worry about, and 68 minus 33, of course, is going to give me something like this. Hooray, I hope I'm right. Sometimes when you get to the next problem, oh, it's not going to do the labeling for you. It's just going to say, here's the angles, you have to do it yourself. So again, keep that in mind, trace things out. I will encourage you, I think I said it in the Google Classroom post itself, have a piece of paper handy or a blank place to write on your iPads just so that you can follow along with this very easily. You'll see the next 3 sections here. I'll go back to home so you can see it from the main screen. Vertical adjacent complementary angles, L1, L2, and algebraic. L1 is going to be mostly simple, mostly just a pair of lines that intersect. Again, if you're ever curious, you can go to example problems, see what it means, see what you'd have to go through with that. But if you can just enter in those numbers, you're going to be good for those. I'm not going to even go through one of those. I'll go to a question like this instead, where there's a lot of things happening. There might be multiple intersections. There might be more than just 2 lines going through a single point. You're going to have to deal with all of those and answer all of the missing letters. The only thing I think I want to mention here is to keep in mind what that little box means next to the D in this drawing, which of course is a right angle. So your right angle is always going to be the same thing, 90 degrees. Just keep that in mind when you do it. Then of course there's vertical adjacent complementary algebraic. You will have to do some solve for x kind of things. Again, definitely have yourself a spare piece of paper handy for this so that you can have a place to write down the fact that for this problem, 9e plus 90 degrees plus 5e plus 6 is equal to an entire straight line. Now, the bad thing about delta math is that if I try to draw on this with my Apple Pencil right now, nope, I'm just moving the entire screen around. So it's not going to give you the ability to doodle right on this page. Again, have a piece of paper, have a spare application on your iPad ready to go so you can find out what that is. Again, don't want to waste too much time with this. The last one is angle terminology with equations. This is going to look like several questions that you saw in the packet where it does not give you a drawing. I believe the questions that we did in the packet said complementary for all of them. This one will give you supplementary, it may give you vertical, it may give you complementary. And you just have to remember what those words mean. Supplementary here says, here are two angles that add to equal 180 degrees, so congratulations. Angle 1 plus angle 2 will equal 180 degrees. Those are the only types of questions I'm going to be asking you on this assignment. And again, how many of them are there in total? 3, 5, 3, 2, 7, 5. That is a total of 25 questions. And hopefully, again, you don't find that's the worst thing that I've ever asked you to do or will ever ask you to do. But that's what I'm going to ask of you. By the time we meet on, this is not the due date for you, you're going to have it by the time our next class happens. Before we go, I do want to go back and talk about the prerequisite skills thing because I did see a lot of you were able to get through most, if not all of these sections on your own, which was awesome. I do want to talk about one particular section that was giving people some difficulty. That was this guided elimination thing. A lot of people had issues with what these boxes were there for and what they were supposed to do. This is actually giving me a pretty difficult question for these examples to start off with, so let me walk you through what I can. Remember when we're doing the elimination method, we're always trying to line it up so that our variables cancel out in some way. Like if my top equation in this example was a 4y instead of a 2y, I'd have 4y minus 4y is 0, it would go away. The guided elimination is simply asking you to pick those numbers yourself and come up with what you need. And any numbers that you type into this box, let me go ahead and just show you fully on my screen. I'll get it as far off as I can. When I type a number into this box right here, you're going to see that equation right above my keyboard. It currently says negative 5x plus 3 equals 0. But when I type something into this box, let's say 8. Oh, look, that equation has already changed to negative 40x plus 24y equals 0. And any number I pick to plug in here is simply going to say what happens when I take that top equation and multiply it by some number. So what you get to do here is, heck, I can do 17 for all I care, or how about 170, or 1,708. It can go ridiculously. But your goal, of course, is to try to do this in the easiest way possible. Like, okay, would you rather cancel x or y in this scenario? That's completely up to you. In this problem, one is not necessarily easier than the other. I do generally think that people like to focus on smaller numbers, though. So if I look at only the y's, I have 3y on the top, I have negative 4y on the bottom. The good news is that I have 1 plus and 1 minus, because that's what I need in the elimination method, 1 to be positive, 1 to be negative. So when I add the two equations together, those terms, the 3y and the negative 4y, somehow will cancel out. But the question becomes, what number should I be looking to make it into? It's really tough to go from 3 directly to 4. It's really tough to go from 4 directly to 3. But luckily, we can just say, let's pick some numbers here that hopefully make a little bit of sense. If you choose, excuse me, the coefficient from the other question, what that means is the number in front of y in equation number 1 is 3. That's what I multiply by in the bottom equation. The number in front of y in the bottom equation is 4. I'm going to multiply the top equation by 4. And you can see now what delta math has done is made those things match. Now I see in this second set of lines down here, I have a positive 12y, I have a negative 12y. Now what delta math isn't going to do, it did the math for you in terms of, hey, I'm putting a number in this box and it's going to change what those numbers were. It was 9x minus 4y equals 7. As soon as I type a 3, that bottom line is 27x minus 12y equals 21. It's not going to do the drawing or the math for you in these boxes. You'll have to put that in yourself. Well, The reason why it starts off with zeros in these boxes is because your goal is to get rid of one of those variables, and 12 minus 12 will give you 0 y's. You'll have to put in the numbers in the other boxes before you click the word try, and it'll let you go through. Negative 20 plus 27, or 27 minus 20, means I'd have 7 x's. 0 plus 21. In elimination method, you're always adding these equations together. As soon as you can get a positive 12 and a negative 12, you're adding the rest of the numbers together. I get 21 here. As soon as I click try, if I've got the right numbers, Delta Math is going to say to me, oh, yeah, cool, solve for x. And that'll be something that is hopefully very easy. And the good news with this problem is when you click the word try, if you put in something that is, I don't know, very, very wrong, let's pick negative 45 here, you have not solved correctly for y, plug in something different and try again. It's not even going to take away one of your answer choices. So just make sure that you're going to do something that makes sense. You're told that x is equal to 3. Well, it's telling you now to plug into one of those equations and solve for y. And whatever it is you're going to have to do to get that is what you're going to have to do. The final answer will then say, put your answer in terms of a coordinate point, and coordinate points are always x comma y. It doesn't matter if you happen to find y first or if you happen to find x first. You're just going to try to throw that into a coordinate point. Always x comma y, your points are always in alphabetical order. So again, I just wanted to put out there what this kind of question was asking you to do. It kind of allows you the freedom to play around with it on your own. In fact, can I just exit this question and say, I could have also chosen to get rid of my x's instead. There's my negative 45x plus 45x. You're going to notice some familiar numbers here. 27 minus 20 is 7. Now it's 35. Okay, I'll find that y is equal to 5. And that's exactly what I would have found in my other question as well. So again, it doesn't matter the order that you find these answers in. What matters is at the end, yeah, I do have to put it in alphabetical order, x comma y at all times. So with that said, I hope that makes it easier for you to complete these kinds of problems. Your only homework will be that other new Delta Math Intro to Angles thing, those 6 sections. Some of them I think will fly by. Some of them you're going to struggle with. Some of them you're going to have to do some more intense algebra, perhaps. Again, have an extra piece of paper handy so it's easier for you. I really hope, again, that by the time our next class rolls around, you'll be able to see me in the front of the room and we'll be able to walk our way through this. So good luck with this. If you have questions at any time, please send me an email. I'll do my best to get back to you as soon as I can. Thanks again. Have a great day.